In this lesson, we cover specular samples. Basically, using specular samples, you can control the quality of the indirect, blurry, or rough specular reflections. So when a camera ray hits a surface with rough specular, or you might say blurry reflections, at the hit point, specular rays will be generated, and the number of those rays can be controlled using specular samples. So you increase this value to reduce the amount of indirect specular noise. This is the scene that we have, and if I open up the material that I have applied to the sphere and the clock, you can see the metalness value is set to 1. That's why we are getting this chrome-like or metallic shader. The roughness value in the specular section is set to 0.2. That's why we get this rough or blurry specular reflections, and if I zero it out, we would have a sharp specular reflections, but let's set it to 0.2 because we want to have a rough specular reflections. Let me get out of the camera. You can see we have these 3 area lights that you can clearly see their reflections on the reflective objects in the IPR. The render you see in the IPR is generated based on the default sampling settings. If I open up the render setting window, for starter, let's zero out transmission, SSS, and volume indirect samples, decrease the camera and diffuse samples to 1. Right now our specular sample is set to 2. Just let's run the IPR, and this is what we're going to get. Like we did in the previous lesson, let's go to our AOVs and add direct and indirect specular, and just let's have our direct and indirect diffuse in case we needed them. Now if I zero out the specular samples, as you can see in the IPR, we'll lose any indirect specular reflections in the scene, but we still have our direct specular reflections from the quad lights that we have. Let's increase our specular samples to 1, and as I do so, we get our indirect speculars back. Specular samples here represents a secondary indirect ray type, not a direct primary ray type. That's why even when I zero out my specular samples, I still can see direct reflections in the scene. We still can see the reflection of the quad lights or area lights on our objects. As I increase my specular samples, we are going to get higher quality indirect specular reflections, basically less noisy. Now let me open up my picture viewer using Shift and F6. The first render I have is with 1 camera samples and 0 specular samples. As you can see, because we don't have any specular samples, there would be no indirect specular reflections, but we still can see the direct specular from the area lights. And if I take a look at the direct and indirect specular AOVs, you see the indirect specular path is completely black, and the direct reflections of the quad lights are visible in the direct specular path. In the second render, we have 1 camera samples, and let's increase our specular samples to 1 as well. Now we start to see indirect speculars. You see the reflections of the backdrop object in the object on it, and also the reflections of the objects in each other. But the whole render and the specular reflections are very noisy. In the next render, let's increase the specular samples to something like 6. And as you can see, we don't have any noise in our indirect specular reflections anymore. We can take a look at the specular indirect AOV for these 3 renders. In the first render, specular samples was set to 0, so this path is black and we don't have any indirect specular reflections. In the second render, when specular samples was set to 1, we introduced indirect specular reflections, but it's very noisy. And in the third render, we increase our specular samples to 6, and now we get this fairly clean indirect specular path. But as it is obvious, the quality of direct specular reflections from the area lights didn't improve by increasing the specular samples, because these are direct reflections from the light sources, and we need to increase our light samples to compensate and get rid of them. In the next render, I increased the light samples from 1 to 4. You'll just select the lights and go to the main tab and increase the samples from 1 to 4. And in the picture viewer, this is the render that we are going to get. It's much cleaner compared to the previous render, and I can compare this render to the previous render and also compare their direct specular AOV. As you can see, by increasing the light samples, we have decreased the noise in the direct specular pass, and also obviously we have cleaner shadows compared to our previous render because of the increase that we did in our light samples. There are still some noise in the indirect specular pass, but in a moment we are going to obviously increase our camera samples and would have a cleaner pass. Also, we need to increase our diffuse samples to clean up the noise in the indirect diffuse pass that we have. We still can see some noise because we have a very low camera samples. In the next render, I increased the camera samples to 3 and diffuse samples to 4. And because we have increased our camera samples, now we have a much bigger specular samples. So 324 is a lot more than 36 that we had a moment before when we had our camera samples set to 1. So we can probably decrease the specular samples. You can do that on your own, and now if we render the scene, we have a very clean render, as you can see in the picture viewer. As a final note, let me tell you that for the specular samples like diffuse transmission, SSS, volume indirect samples, and also light samples, the actual number of samples are input value squared multiplied by the square of the camera samples. So even though we only have 6 specular samples, but if you take a look at the actual specular samples up here, you can see it is 324, because 6 by 6, 36, we have 3 by 3, 9 camera samples, and 36 by 9, 324 samples. So in this lesson, we discuss specular samples, and in the next one, we talk about transmission samples. See you there.